Alright, so for the second video, we're going to do more graphing with systems, but now instead of inequalities, we're going to be graphing systems of equations. And this is easier because we don't have to worry about solid line, dotted line, or any graphing. It's much cleaner, okay? But just some quick basics to kind of review. A system of equations. This is when you have two linear equations. Just like the last system was two inequalities, a system is when you have two problems working together. A system of linear equations may have 1, 0, or an infinite number of solutions. Alright, we'll talk more about that in the next video. Mostly they have one solution, but there's some weird times when they have 0 or infinites. Okay? Just some vocab to be familiar with. Intersecting lines. Those are two lines that cross at one point. And that's called the point of intersection. Okay, so it's like looking at the lines like streets. Two streets that cross, that's an intersection, and they cross at one point typically. Alright? And the solution of the system is the common point of all the lines. Alright, so basically, once again, what that means is when I'm graphing a line, any line at all, that means that every point on the line is an answer, right? Every point's an answer. The whole line is an answer. I'm trying to find that one point where it's the same point on both lines. Okay, so instead of looking where they're both colored on the inequalities, I'm just looking for the one point that's the same on both. Okay? So, thing to remember when you solve your systems is to write your answer like a point, because you're showing the one point that is the same answer, so we're writing it in the form xy. Okay? Alright, so let's go ahead and do a few practice. These are much easier than the inequalities. Both of these equations are y equals mx plus b, so I just graph it. Start with your intercept. Y equals negative x minus 2. My y-intercept is negative 2. There's my first dot. Now remember this, negative x, that means the slope is negative 1 in front of the x. Remember, negative 1, make it a fraction, negative 1 over 1. That means down 1, right 1. So start here and go down 1, right 1. And equations just have a solid line, so I don't have to worry about what kind of line. Okay, but I do want to try to be neat and draw it as neatly as possible so I can see where it's crossing together. Okay? Now I'm going to go to the second equation. Y equals negative 4x plus 1. Y-intercept is positive 1 this time. Slope is negative 4, which means negative 4 over 1. That means down 4, right 1. So we're just going to go 1, 2, 3, 4 down, right 1. And it's on that same point as the other one. And that's fine. That's supposed to happen. Alright, and then we're going to get our ruler, draw a straight line. Okay, so we're not done. Now I have to label my answer. This is my answer. This is the point that is the same point on both lines. So now I'm just going to write that as a point. So remember, you start at the origin, the middle. And how do I get there? Well, on the x first, I go positive 1. And then I go down 3, negative 3 on the y. That's my answer. 1, negative 3 is an answer for both. That's it. Alright, let's try number 2. Now I got these two equations. They're both in y equals mx plus b form, so I can graph these. Alright, now remember though, that looks weird, right? It's only got one letter. So that's when I use the shortcut. That's when I use my Hoivux. This x is a Vux line. It's vertical at this point. So I'm going to go to 3 on the x, because it says x equals 3. And I'm just going to make a vertical line there. There's my first line. Alright. Now I'm going to graph the second one. Positive 4 is my intercept, my y-intercept. Slope is negative 2/3, so we'll make the top number negative. So we'll go down 2, right 3. Down 2, right 3. Get your ruler, and we're going to connect those lines. And then we can see where is our common point or our point of intersection. Right there. That's the point that's the same on both. So we'll write the answer like a point, starting at the origin. To get here, we go on the x, positive 3. And then we go up, positive 2 on the y. So that's the point, or the answer for that point, I should say. Okay? For now, we'll skip 3. Okay, the only thing I really want you to take away from 3, this is a bad problem because it totally doesn't fit on the graph. But hopefully if you look at this, you'll realize that, okay, this equation I can graph. That's in y equals mx plus b form. This one I need to solve. And it doesn't look exactly like the ones we've been solving recently, but you've done equations like this back in chapter 2. So just, what we want to kind of see here is it doesn't matter how it looks. If we have to solve it, we have to solve it. We're getting the y by itself. So if you look here, hopefully you remember that, oh yeah, I know how to do this. I distribute first. So the y minus 5 stays on the left side. 2 times x is 2x. 2 times positive 1 is positive 2. And then I'm getting rid of the stuff by doing the opposite. Get rid of the minus 5 by doing plus 5. And I'm going to put that here because these don't have x's. They're like terms. So this equation will be y equals 2x plus 7. So because the intercept's way off. But once again, it's just solving it by getting the letter by itself. That's the only thing to really get from here. Okay? So we'll skip graphing that one. Alright, number 4 now. Okay, so for problem number 4, if you look at both of these, you're going to see we got to solve both of these. Okay, it's going to take a little bit of work here before we can graph. So let's go ahead and just take each problem here. Alright, first equation is 2x minus 3y equals negative 9. We wanted y equals mx plus b, y by itself. So our first step is to subtract 2x. That cancels that out, and we're left with negative 3y equals, put the x first, negative 2x minus 9. Okay? And then final step. Remember, read what's happening. Negative 3y means negative 3 times y. Opposite is divide by negative 3. Divide everything by negative 3. That's canceled out. Y is by itself. That's what we want. Negative 2 over 3. Remember, if you don't recognize that, use your calculator. Do negative 2 divided by negative 3. When it gives you a decimal, put it back into a fraction. It'll simplify it and everything. Alright, so simplified is just positive 2 over 3. That's all. So it's positive 2 over 3x. And then negative 9 divided by negative 3 will be positive 3. Alright, so don't look at this anymore. This is now what we're looking at. So let's go ahead and graph that now. Y-intercept, start there as positive 3. And then the slope is 2 over 3. Okay, so that's 2 over 3. That means up 2, right 3. Up 2, right 3. And we'll get our ruler and make a nice straight line here. Alright, now we're going to do the second equation. 5x plus 3y equals negative 12, and we're going to solve this one now. Getting y by itself as always, we will do minus 5x on both sides first. The left side is just 3y equals, put that negative 5x first, and it was a negative 12, so it's minus 12. Alright, and now divide, because that's the opposite of multiplying by 3. Divide everything by 3. And we have y equals negative 5 over 3. If you punch that in your calculator and change it back, it comes back to negative 5 over 3x. Doesn't change. Negative 12 over 3 is negative 4. So don't worry about this. Now look at this. Y-intercept is negative 4. Now my slope is negative 5 over 3. That means down 5, right 3. And we're going to have a problem because if I start here and go down 5, I'm way off the graph. So just remember, think about this with the line. Think about what we did in chapter 4. Whether I go this way or this way, it's the same slope, right? So it's kind of like just going opposite or reversing it. So instead of negative 5, make it positive 5. Instead of positive 3, make it negative 3. So you see what that means? Instead of going down 5, we're going to go up 5. Instead of going right 5, we're going to go left 5. Now it's going to fit. So I start here and I go up 5 and left 3. Okay, so that doesn't happen a lot, but if it ever does happen where it doesn't fit, then just do it the opposite. Alright? And so then here's our point of intersection. That means our answer for this point would be -3, +1. Just like that. Okay? Alright, a couple ones where we're checking a solution. Alright? So number 5 is asking, is 1, 2, is this point a solution to this system? So let's first start by doing the algebra, plugging it in. Okay? So remember, first number is the x, second number is the y. So if I plug it into the first one, y is 2 equals. Now remember, I'm just going to type this in, plugging in 1 for x with parentheses in my calculator. So it's -3, x was 1, and it said +5. The calculator will do the PEMDAS and everything for me, and I get +2. So look, 2 equals 2. That's true. So the first one was good, but remember, I got to check them both. They have to both be good. So now I'm going to plug this x and y in here. I'm going to plug 1 in here and 2 in here for the y. Okay, so we're going to go to our calculator now. 5x, 5 parentheses, x is 1, and then it said -4y. -4 parentheses, y is 2. Remember, substitute with parentheses and we get -3. So the left side is -3, then look at the right side, -3. Okay, so because they both check out, our final answer is yes. That point is a solution. Okay, now just real quick, I'm going to pause it. We're going to show how to use the graph as well. Okay, so when you, just in a second, it's going to jump and it'll have the two equations graphed to see on the graph if it's the answer. Alright, so for number 5, here's what these two equations look like graphed. This one was ready to solve, this one you have to solve it. But I'm checking 1, 2. So look, if I go to 1, 2, that's 1, 2. That is on one line, but it's close but not on the other. Actually, I'm sorry, I take that back. I drew this a little off. It will be on both on the intersection. My bad. Alright, so because in here it's the same answer for both, that is why it is in fact the same answer. Okay? Alright, last one, number 6. Now we're checking, is this point 2, 1 an answer to these equations? So once again, we're just going to start the easy way. I think plugging in is probably the easiest. So we're going to plug in 2 for the x, 1 for the y, and go to our calculator. 2x x was 2, minus 3, y is 1. So the left side of that will be +1. And then it equals, look what's on the other side. Let me come back here. 2, yeah. So as you can see, where is this? Yeah. This left side said 1, this is -1. Be careful, that's positive, that's negative, that's not the same. So that's not true. That means this is wrong. This is not an answer. So I don't even have to check the second one. I can already say no, that's not an answer. Okay? But just to once again see it on the graph. I'm going to pause this, make the graph. The graph will pop up and we can see how to use the graph in just a sec here. Alright, so for this system, here are the graph of these two lines. This one had to be solved. And if I check 2, 1, point 2, 1 is right here. So as you can see, this is the answer for one of the equations, but not for both. It has to be, like this one where it's the point for both at the same time. Alright, so that's how you graph system, and that's how you also can check them. Remember, you can either plug it in or graphing, whichever way you prefer. Alright, so now it's time for you to practice.